In today's video, I will be going over the Unit 6.1 test review. We have 10 problems to do here. And for this video, you'll of course need your calculator, and make sure your calculator is set to degrees. And then I'm going to be using the reference sheet that you'll be getting on the test, just so you know exactly what you will have to use. So on the reference sheet, we have the law of cosines, all three forms of it. Heron's formula for area, which is used for the three sides of the triangle. So A, B, and C, they're all lowercase. You have to know all three sides if you're going to use it. That isn't specifically mentioned, but if you know that these lowercase letters on the triangle represent the sides, you'll be fine. And then the SAS triangle formulas for area, if you choose to use that formula instead. You'll use, it depends on which two sides and angle you are given or which pieces of information you choose to use. So there's three variations as well. Hopefully you notice that there is something missing from this reference sheet, and it's the law of sines. That will not be given to you. That is the one thing you will have to have memorized for this test. So make sure you know what the law of sines is when you do these. So I'll go ahead and write that out. Law of sines, we have sine of A over side A, lowercase a, sine of B over B, and sine of C over C. So now we have everything we need to know to solve these problems. And as you can see, I'll have to do this on my own piece of paper. First problem. In the first 6 problems, these are all solving problems completely, and per usual, we'll round to the nearest tenth for our answers. First problem, number 1. I'm going to write down the givens. Measure of angle A is 63 degrees. Side A is 18, and side B is 15. So first off, I'll just draw my triangle, see what we're working with here. And we have A, B, C. A is 63 degrees. Oh, and I forgot to label the sides. A, B, C. Side A is 18, side B is 15, side C we don't know. So these are the 3 givens. Before we do anything, we want to identify what type of triangle we have, because depending on the type, that affects how we approach solving. So we have an angle right here, and then we have 2 sides. And if we start at the angle and follow the sides, it's like we're going around from there. It's not the 2 sides that are sandwiching this angle in. So this is not SAS, this is ASS. Now remember, ASS is the ambiguous case. It's the case where there could be 2 triangles potentially. Now we don't know that for certain, but you have to look for it. You won't know for sure unless you actively check for that. So we create triangle 1 and triangle 2. So this is triangle 1 here. And then I'll make a second triangle, triangle 2. Now I won't draw this triangle yet. This is something that will come up later. So for now we start solving and then we just go from there. So the first thing we can do, we have both A's. So when you have the same letter and you have the angle and side for that letter, that's when you're able to use law of sines, because you can complete one of these fractions. And we can complete the A. So I'm going to start with sine of A. Sine of A over A equals, and then the other piece of information we have is we have side B, so we can then find angle B. So this is the first thing we'll set up. That means we are looking for side B here, or sorry, angle B. Since we know angle A, side A, and side B, we're looking for angle B. filling in our numbers, we have sine of A is 63 over little a is 18, little b is 15, and then we don't know angle B, so this will stay sine of B. Next we cross multiply. I will show the algebra fully on here one time for this. Any other problems that I have to solve like this, I'm just going to do the shortened version. So, going through the full algebra, I'm going to cross left first. We have 15 sine of 63 equals, crossing left or right, 18 sine of B. And if it helps, write the times there so you know what to do next, because that's what we just did. We multiplied them. And from here we solve. First thing I need to do is get sine of B by itself, so I'll divide off that 18 on both sides. Don't put anything in the calculator yet. 15 sine of 63 over 18 equals sine of B. Next we have to remove that sine and we have to move it to the other side. When this switches sides, that's when we use the inverse and we use that -1. So over here, since it's flipping sides, it's now the inverse sine. And then you drop that whole fraction into the parentheses. And now since it moved, we just have the B. And then I'll use my calculator to get that. And then we'll round B to the 10th place using the calculator. Okay, second sine, and then alpha x to get the fraction to pop up. 15 sine of 63 over sine, nope, no sine, just 18. Okay, and then we round that to the 10th place, we get 47.9. So that is angle B. (47.9 degrees). All right. Now, a reminder, this is an ASS problem, so just kind of reiterating the importance of this and why we have to have the second triangle. When we have to use inverse sine to solve, the largest number that can come out of that we could get for this answer is 90. So that means any angles between 90 and 180, your obtuse angles, we can't get that answer from inverse sine. And so inverse sine is a flawed way to solve, but it's our only option, so we're forced to use it. So to kind of make up for the fact that this can't give us obtuse angles, we have to then go and see if we can make a second triangle and ask the question, could B have been obtuse? Should B have been obtuse? But I couldn't get that number because inverse sine wouldn't let me. So that's where triangle number 2 comes from. So our alternative triangle is testing if B could be something else, could be an obtuse angle. So I'm going to stretch this out and make this a wider angle just to demonstrate that point. Didn't do a very good job at it, but let's just imagine. I'm going to draw that again. That's going to bother me actually. So give me just a sec here. Okay. I'm going to fix it. Just give me a sec. Okay. It's an ugly triangle, but I think you get the point. I'm trying to make this an obtuse angle, so sorry about that. Okay, so this is triangle number 2. ABC. And when you draw triangle number 2, everything given remains the same. So that information doesn't change. So A is still 63 degrees. And then let me label the sides. A, B, C. Side A is still 18 and side B is still 15. So that part remains unchanged. The question is, could we have a scenario where B is actually supposed to be obtuse? But again, we weren't able to solve for that. There's no way we can get that answer. So we have to find an alternative angle for B. So this we are testing for is obtuse B. Okay, so what we do, if you remember, is we do 180 minus what we got for the original B value, 47.9. And we get 132.1. So that means angle B is 132.1 degrees. Now to see if this triangle actually works, we're going to find angle C. And some of you already know where this is going if you're looking at those numbers the way I am, but if you're not, let's take this a step further. Let's find angle C for triangle 2. So we're going to use these two angles, 180 minus 63 minus 132.1. And we get a negative value. Now obviously you cannot have a negative angle inside of a triangle. We can do negatives on the circle, but not inside of a triangle. Can't have a negative angle. So, since this clearly doesn't work, this is the case where ASS only gives one triangle, not two. We're just going to write here, and you can put it where you can fit it, or we're just going to put it under triangle 2. No second triangle. So we're going to leave that as it is. So triangle number 2 did not work out after all. So now all we have to do is finish solving the original triangle. And I have two pieces left. I have to find angle C and side C. Angle C will only take a moment to solve for, as I can use the fact that this whole thing is 180 to find it. So I'm going to write that out real quick. So we have measure of angle C, 180 minus the two angles. We have 63 for A and then 47 point B. 47 point B, my goodness. 47.9 degrees for B. Then I'll subtract those in my calculator. Just steal this real quick. Okay. 69.1 degrees. So that is the measure of angle C. So now we know angle C is 69.1 degrees. On the test, we provide an answer box, so you can fill in the whole triangle, but we put a box there for you to write in everything yourself. Okay, now all we have to do is find side C, and then we're done. Side C. Side C, we are able to use law of sines to find that, and per usual, I'm going to use the givens to find that. That's what I always use. We were given the A's, so I'm going to set up sine of A over A, and again, I'm using this because it was given, equals sine of C over C, and I'm using C because that's what I'm looking for. Sine of A is 63, and little a is 18, equals sine of angle C we just found to be 69.1 over side C. Again, this is the only time in this video that I will show the full algebra for law of sines. On any future problems, I will take some shortcuts. I'll explain what I'm doing, but I won't write it out. Okay, crossing left, we have sine of 63. And again, I recommend writing that times C, create some separation here. Equals, crossing right, 18 sine of 69.1. And then we solve. This is a very quick thing to solve. We just need to get the c by itself. So divide off the sine of 63 on both sides. C equals 18 sine of 69.1 over sine of 63. Now the majority of you follow my instructions on this, but I have a few students who do their own thing. On the test, before this part, do not put anything in the calculator. Do not put any of these signs in the calculator and round and then try to get the answer. It throws off the answer more than you would think. So not worth it. Wait until you are completely solved, then get in the calculator and round. Alpha x, we have 18 sine of 69.1 over sine of 63. Rounding, we have 18.9. And our triangle is completely solved. We had the 3 givens and the 3 missings. They have all been found, and we found out that there was no second triangle, so that would cover that answer over there. 1 down, 9 to go. All right, number 2. The givens are a equals 5, b equals 3, and c equals 7. Drawing my triangle ABC, and little a, little b, little c. A is 5, b is 3, c is 7. So this is clearly side, side, side. We have all 3 sides. So not the ASS case, 1 triangle, 1 answer. Let's solve. Side, side, side. If you get to recognize the types of triangles with their solution methods, this is a law of cosines problem. We cannot use law of sines because we know none of the angles. So we are forced into using law of cosines. Now the good news is we can use any of these 3 variations because we know all 3 sides. It's just about which angle you want to solve for first, and it doesn't matter. So I'll just go in alphabetical order. I'm going to go with the first formula here. When you do these, just because of how complicated the formula is, I strongly recommend you just write this out first, then start plugging things in. Okay, so the first thing we're going to do is find angle A. Our law of cosines that we're using, a squared equals b squared plus c squared minus 2bc cosine of a. I'll plug everything in. A is 5, b is 3, c is 7, okay. So we have 5 squared equals 3 squared plus 7 squared minus 2 times 3 times 7. Cosine of the A, we don't know, so A is still A. This is the type of problem where there's a lot of algebra, so make sure when you are doing these problems, you are following your order of operations at all times. Okay. First thing I'm going to do, we do exponents, so I'm going to square all of these. So we have 25 equals 3 squared is 9 plus 49. And then I will go ahead and multiply these numbers together. 2 times 3 times 7, that's 42. Okay. Next thing we can do is we can add the 9 and the 49. So we have 25 equals, that's 58. Minus 42, cosine of A. Next, we do not do 58 minus 42. 42 is attached to the cosine by multiplication. So what we're going to do instead is move 58 over here. Minus 58, minus 58. And I think that's negative 33, but I'm just going to check to be sure. Don't want to make any mistakes. Yep. Negative 33 equals negative 42 cosine of A. Now we divide off that negative 42 on both sides. So then we have, and you can cancel out the negatives or keep them there. I really don't care. I'm just going to go ahead and cancel them out. 33 over 42 equals cosine of A. And then we talked about it before with the sign. When you want to flip sides with the cosine, you need to use the inverse. So we're going to have inverse cosine of that fraction so that it can switch sides equals A. And then I will round A accordingly. Second, make sure you hit cosine and not sine this time. Alpha x, we have 33 over 42. 38.2 degrees. So this is angle A. All right, there's one of three angles. Now we have to unfortunately do this whole process again for another angle, and then we can use 180 to get the final angle. So again, I'm going to go alphabetical order, and I'll solve for B next. For those of you who are like, oh, now I have both A's, I can use law of sines. Because of that ASS possibility happening when we are, obviously this is not an ASS problem, we see that. But when you use law of sines and you're solving for a B or C, you're going to have to use the inverse sine, just like we did on the previous problem. We had to use inverse sine because we were finding an angle. You would run into that same issue here because we're looking for an angle. So if you use inverse sine and the one you were solving for is the one that could lead to that second triangle, that's causing issues. So my rule of thumb to avoid that mistake is if you start with law of cosines, you finish with law of cosines. So I'm going to do law of cosines again. I'm going in alphabetical order, so I will find angle B next. This time I'm going to use the second law of cosines equation since I want B. We have B squared equals A squared plus C squared minus 2AC cosine of B. Plugging in, B is 3, A is 5, C is 7. Then we have 5 and 7. 3 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 cosine of B. I'll condense the steps a little bit this time. We have 9 equals, and then I'm going to go ahead and do this part entirely in the calculator. It's 25 and 49. 74 minus that's 70 cosine of B. Again, resist the urge to subtract these. Can't do it because of the cosine. So minus 74 on both sides. 9 minus 74, that's negative 65 equals negative 70 cosine of B. Next, we divide both sides by the negative 70. And then that's going to cancel the negatives, so we'll just have 65 over 70 equals cosine of B. And then next, we will use the inverse cosine to move cosine to the left side of the problem. And then we round B using cosine. 21.8 degrees. Lastly, we need to find C. And we know 3 of the angles, so that part's going to be easy. Measure of angle C. We have 180 minus 38.2 and 21.8. $120. So that is our final angle. Next problem. Number 3. We are given measure of angle B is 47 degrees. Measure of angle C is 62 degrees. And A is 10. First thing I'll do is draw the triangle ABC. And then the sides ABC. Let's see, angle B is 47 degrees, angle C is 62 degrees, and side A is 10. And we have an angle here, a side here, and an angle here. Hopefully you can clearly see this spells out ASA. We have a side in between the 2 angles. Okay. So if we look and ask ourselves, how can we solve this problem? We do not currently have a matching pair, side and angle with the same letter that we can solve with law of sines. But we also don't have enough information to use law of cosines either. All we have is one side and 2 of the angles. And all 3 formulas only have one of the 3 angles. So that's not going to work. So hopefully you already see what the first course of action is going to be. We need to find angle A. Once we find angle A, we can use the A's and law of sines to solve. So I'm going to do that over here first. We have 180 minus 47 and 62. $71 degrees. So anytime you're given 2 of the 3 angles, the very first thing you do is you find the 3rd angle. And sometimes that's the only thing you can do right out of the gate. Okay, next we now have a completed pair of letters, angle and side, that we can use to set up law of sines. So next, our end goal is to find B and C. We can find those in either order. So I'll just go in alphabetical order, and I'll start by finding B. So we're given the A's. So I'm using those because they're given, and they're the only option right now. And then I want to find B. So sine of B over B. Filling in, we have sine of A is 71, and then side A is 10, equals sine of angle B, which is 47. And then we know what side B is. Or no, we don't know what side B is. We're solving for it. Now, as promised, I am not going to show the algebra. I'm just going to talk you through it and then write out the setup of the answer. I'm just going to go up and over here. So if we were to do the algebra, this is how it would end up. Whatever gets crossed with b, that's what we're going to divide by. So that goes on bottom. So the other two numbers that get crossed, those will be multiplied on top. 10 sine of 47. There's the setup. And then calculator to solve, or to get the answer. Alpha x, we have 10 sine of 47 over sine of 71. $7.7. So that's side B. And side C, and I will repeat that to find side C. As I mentioned before, now I could technically use the A's or the B's to find C, but I always go with the given numbers. I try to avoid any numbers that I had to round, like the B for instance, to find other answers that are also going to be rounded. It's just going to throw the answers off that much more. So it's best to always use what you're given. So again, I will use the A's. And this time that choice is because that was given, not because it was the only choice I had. And then this time we want C. Filling in, we have sine of 71 over 10 equals sine of angle C is 62 over C. And then we'll cross multiply. And then setting up the answer, we have C equals, we're crossing with sine of 71, so that will go on bottom. That's what we divide by. And then these two numbers that get crossed, they're multiplied on top. 10 sine of 62. If it's still helpful for you to do the algebra completely, then do that. But if you can follow the shortcut, it does save you some time. All right. And as you can see, this is almost exactly what I typed in before. Just got to change 47 to 62. 9.3. That is side C. And there you have it. There's our completed triangle. Number 4. Our givens, the measure of angle A is 53 degrees. C is 17 and B is 20. So we'll draw our triangle. A, B, C. Little a, little b, little c. Angle A is 53 degrees. Side C is 17, side B is 20. First we look at the setup. We have our two sides with an angle in between. Hopefully you can see that this spells out SAS. So this is the one setup where it's not ASS, and the difference is we have the A directly in between the two sides. It's sandwiching the angles between it. You can also see it as the two sides that create that angle. But it's not two sides and then a random angle over here. That would be ASS. SAS. So we only have one angle. We can't find B or C. So looking at this, we don't have the pair of angle and side like we would need to use law of sines. SAS automatically means that this is a law of cosines problem. And when you have this setup, we only know specific information, so only one of these is going to work. And if you use the wrong one, you will more than likely realize it because you won't be able to solve. You'll be missing too much information. Now we're going to have to use, since we have angle A, we're going to have to use the first formula. And I know this because we know everything on the right side. We know sides B and C. That covers this part. And we know angle A. We're only missing side A. If we try to use the other formulas, we're missing side A for both formulas and those two angles. So in both of the other formulas, we're missing two things. You can only be missing one thing if you're going to use a formula. Successfully, I should say. So, with that in mind, I'm going to use the first formula and we're going to be solving for A. That's what we'll get out of it. So I'm going to write out the formula. We have A squared equals B squared plus C squared minus 2BC cosine of A. Filling in our information. This is still A squared. We have B is 20, C is 17. 20, 17. And then angle A is 53 degrees. So we have 20 squared plus 17 squared minus 2 times 20 times 17 cosine of 53. Now luckily this is the easier version of the law of cosines where we can just use our calculator to get this. Now before we do that, let's do one more step. This will save us some time. To fully solve for A, we'll need to square root both sides. So then I'm going to put this entire thing under the radical into my calculator. That will be my answer. Don't forget the radical because obviously that would be a major mistake. Now this is tedious to type in. Clearly it's going to take me a minute. So when you do this, take your time and type carefully. Any change in the numbers or using the wrong symbol will get you the wrong answer for sure. And what I like to do is I'll go ahead and hit enter, but I will kind of just go back and look through it. Now to do this, I'm going to have to copy and paste it so I can see the front part, pretty much all of it. Actually, I can see all of it right there. I'm fine. Just do a quick look and make sure everything's there the way it's supposed to be. So we've got 16.7 for A. So now we know side A, 16.7. Once again, we're looking at this. Oh, now I can use law of cosines or law of sines. It's gonna be faster for sure. But again, if used improperly and if you use it to solve for a specific angle, again, I'm not going to dive too deeply into that, but depending on which angle you choose, you might be making a mistake because of that inverse sign. So let's not do that. Let's do law of cosines. You start with law of cosines, you will end with law of cosines. From here, I can find angle B or C. I'm going to go with angle B. Now, since I want to find B, I will be using the second version of the formula. B squared equals A squared plus C squared minus 2AC cosine of B. Filling in, B is 20. A, we now know, is 16.7. C is 17. Filling in my symbols here. And there we have it. Now this is the more painful, more algebra intensive version of the law of cosines. So this is going to take several steps. 20 squared is 400 equals, I will use my calculator and I'll go ahead and do this part. I'll get that whole number. 16.7 squared plus 17 squared. And that's not a bad decimal at all, so do not round it. And just a note on that, that's kind of a hard call to make mid-problem if you end up with a really long decimal. If you end up with something short, and for me short is like 4 places or less, just use the number they give you. If they give you something very long that clearly needs to be rounded, my rule of thumb is go out 4 places. It seems extreme, but if you go out 4 places, then it will not throw off the rounding for sure. But 1 or 2 places, absolutely, there could be a rounding error as a result. I'll go ahead and multiply these together as well. $567.8. Interesting. Okay, next, again, resist the temptation to subtract these. You're not allowed because of the cosine. So what we're going to do instead is subtract 567.89 on both sides. And that gives us negative 167.8 equals, don't forget that negative up here, negative 567.8 cosine of b. Next we divide both sides, negative 567.8. These will cancel, just get us a positive 167.8 equals cosine of b. And then we want to flip that over to the other side, so we will need inverse cosine to accomplish that. And then we will use that, round it to get the b value. Don't forget to do inverse cosine, not sine. Alpha x, 167.8 over 567.8. 72.8. So that is angle B. And lastly, we need to find angle C, which thankfully we have 2 of the 3 angles, so we can use the shortcut on that. Measure of angle C. 180 minus angle A was 53 degrees. Minus B was 72.8. $54.2 degrees. That is angle C. All right, so there's number 4. We've only got 2 solving problems left. Once we hit the area problems, those are going to go a lot faster. Number 5. Measure of angle B is 38 degrees. A is 16 and B is 12. Setting up our triangle here. A, B, C. Little a, little b, little c. Okay, we know that angle B is 38 degrees. Side A is 16 and side B is 12. First, let's classify it. Don't forget to do that. We have an angle, a side, and another side. So yes, we have an ASS case. So you can see it's an angle, and then the next 2 sides after it, it's not the angle that's between these 2 sides. That would be C. ASS means this is going to require some more work. So set up triangle 1 and 2 before you do anything else. All right. Okay, so looking at this, we have both B's and then A. So we are going to be finding angle A first. Angle A is going to be the questionable one. So if you already kind of look ahead like I am now, I can go ahead and set up the second triangle. It's angle A that we're not sure what it's going to be doing. So this is going to be the one that is possibly obtuse. But I will draw that later. I just wanted to point that out now. Okay, so let's just start the problem as normal and then go from there. So we're looking for angle A, since that's the only thing we can do right now. So we need the B's, because the B's are the complete pair. They're the givens. Sin of B over B equals, and then I need the A's if I'm going to solve for that. Sine of B is 38 over side B is 12. And then I'll go ahead and fill in side A is 16. So here's our setup. And then reminder, I've already done this fully, like full out, with the algebra explained on number 1. So I'm not going to do it again. I will talk you through what I'm doing, but I'm not going to show all the work. So if we cross multiply, we'll end up with sine of A is equal to, I'll do this in 2 steps. Whatever gets crossed with sine of A, that's going to actually get divided. So the 12 just goes on bottom by itself. And then the 2 numbers that get multiplied across from each other, they are going to go together on the top. 16 sine of 38. So here's where the algebra would lead, and then we need to do inverse sine to get A solved for. So A equals inverse sine. It might be too small, but it will. 16 sine of 38 over 12. And then we use our calculator to get that answer. So this time we're doing inverse sine, so second sine. Make sure you're paying attention to that. Alpha x to get the fraction. 16 sine of 38 over 12. 55. And finally, we get to actually round a number up. 55.2. Degrees. So this is our first answer. Now remember, anytime you use inverse sine, that raises the question, did I get this answer because this is really the answer, or did I get it because it won't give me the obtuse version of that answer? So that's why we have to ask the question, is there a second triangle that could work? I promise you I will draw it better this time. So angle A is the one that could possibly be obtuse. So I'm going to draw an obtuse angle, and I'm going to draw the obtuse angle first, and then finish the triangle, unlike last time, which is why it was so poorly drawn. Even after 2 years of teaching geometry, I still struggle with drawing obtuse. I don't know what it is. It's just awkward. Okay. Now the positions are still the same. B is still up here. This is still A, and this is still C. Givens are still the same. Let me write down the sides first. Okay. Angle B is still 38 degrees. Side A is still 16, and side B is still 12. That's all the same. From here, we need to find the other option that A could be. So we're going to find obtuse angle A. And so we do 180 minus the original angle A that we got, 55.2. It's 124.8. Got markers everywhere. So this is the other option for angle A. To verify that this is going to work, let's find angle C, which we just use 180. 180 minus 38 minus 124.8. Angle C, the remaining degrees left in the triangle is 17.2. Since this worked, this is a legit triangle. We are going to have two answers here. So there's not great news here. That means we have to do more work to finish the problem, but the work itself is not bad. We are almost done. So from here, let's kind of just, take a step back and see what we need to do. For the second triangle, we still need to find side C, and that's it. For the original triangle, because we're not done with the original triangle, we still need to find angle C and side C. So an angle C will only take a moment to find. We can use 180 to get there. From here, the order in which we do the problem depends on the person. If you think you can quickly finish triangle 2 and then remember to return to triangle 1, then you can do that. If you want to finish triangle 1, then finish triangle 2 to make sure you don't forget, whatever works for you. Since I'm already on triangle 2, I will go ahead and finish it. That just makes more sense to me. But you just want to make sure you don't forget to finish the problem when it's all said and done. So, and this is a big reason why I color code, because the work gets a little chaotic after that. On top of that, since I'm sure you guys are probably doing this in pencil the whole time, this is more for you and less for us grading, but it may be helpful if you label the original triangle with 1s, and I only do this after I know I have 2 triangles. If I don't have 2 triangles, I don't bother with this. But go ahead and, now that we know we have 1 triangle, 2 triangles, we have triangle 1, triangle 2, I label everything with 1s on the first triangle and then everything with 2s on the second triangle. And like I said, I think the color coding makes it obvious which triangle I'm working with at all times, but even still, the numbering does help kind of put that, understand what you're doing. So I'm going to label this as well, angle 1, or A1 over here, just to make it easier. Okay, triangle number 2. So I'm going to finish solving this guy first, and I know I just showed you the work, but I always like to write it out just to be sure. I'm going to write out the work for C2 real quick. 180 minus, it was 38 and 124.8. And we got 17.2 degrees. Okay, so next, I'm going to draw a dividing line here since my work is now separate as well. Next, we will find side C. C2, technically. Since I'm working on the second triangle right now. So to find side C, I'm going to use law of sines, of course. I have the B's, both B's, and these were the given ones. That's why they're in purple. So I'm going to use these, not the A's, since I had to round this number. Okay, so we have sine of B over B, and again, I'm choosing this because it's given. And then sine of C over C. And I'm going to label these with 2's just to further emphasize I am in triangle 2, not triangle 1. Okay, sine of B, which the B's are the same in both triangles, so I guess that's nice. 38 over 12 equals sine of angle C is 17.2, and then side C, we don't know. We're solving for it. Okay. Cross multiply, and reminder, I will not be showing you all the algebra for this. I will just talk you through it. C equals, we cross multiply, whatever gets crossed with C goes on bottom. That's what we divide by. So the other two numbers that get crossed, they are multiplied on top. And then we round. This is C2. Okay, we have alpha x, 12 sine of 17.2, over sine of 38. 5.8. That is side C2. So we have the 3 givens and the 3 missings solved for. So triangle 2 is completely solved. Now we go back and finish triangle 1. Don't forget it. We are missing, again, just like in triangle 1, we're missing angle C and side C. So angle C is very quick to find. We just use 180 to get there. So now I'm looking for angle C, C1, not C2. We have 180 minus, we were given, I'm going to write out A first. A was 55.2 minus 38, which was B. $86.8. Okay. Lastly, we need to find C1. So I'm out of space. I will get a different piece of paper to finish that up on. So we are finding side C1, side C, triangle 1. Just like how I did it when I solved for triangle 2, same logic applies. I'm given the B's, so I'm going to use the B's to solve, and then I, of course, have to set up the C's. And we're setting up law of sines. Sine of B over B, and again, I am using the B's because it was given. And then we need C's. Sine of C over C. And we are in the first triangle. So then, let's fill in. I don't know C1. B, angle B is 38 degrees. Side B is 12. And then C1 is 86.8. I just found that number. Okay. And then I'm going to cross multiply. C1 equals, I'm going to set it up. Whatever gets crossed with C goes on bottom, sine of 38. The other two numbers cross on top. 12 sine of 86.8. And then finally we use the calculator to get that answer. Good news, it should be similar to what I typed in last time. Yeah, just got to change the top. Angle 86.8 on top. Yep. 19.5. Okay, here is a full-length ASS, the ambiguous case problem, where you have to fully solve for both triangles. I honestly think it's not horrible, but obviously, as you can see, it's a lot of work and there's a lot to follow. So you just have to go through it step by step and do your steps in your algebra carefully. There's only one of those on the study guide, thankfully. So that is definitely the longest problem I'm going to be doing. We have one more triangle to solve, and then 4 areas to find. Okay, number 6. Measure of angle A equals 120 degrees. Measure of angle B is 23 degrees. And B is 8. Side B is 8. All right, draw the triangle. A, B, C. little a, little b, little c. Filling in, angle A is 120, angle B is 23 degrees, and side B is 8. Let's classify first. I have an angle here, and a side here. So we have the A's are next to each other, and this side is kind of off by itself. This is the AAS case. Right off the bat, looking at it, notice a couple things. Number one, we can dive in with law of sines if we wanted to, because we do have both B's. But also we do have 2 of the 3 angles, so we could go ahead and find C. Let's do that first, since that's clearly going to be very quick to do. So let's find angle C first, then I'll backtrack and use law of sines with the B's. We have 180 minus 120 and 23. And we just get a nice 37 degrees for angle C. Next, we just need to find A or C. We can go in any order. I always default to alphabetical order, so I'm going to find A. So, like I said, we can use law of sines since we know both B values. Sine of B over B is equal to sine of, we need the A's. A over A. So angle B is 23, side B is 8, angle A is 120, and we don't know what side A is. Cross multiply. A equals, whatever gets crossed with A goes on bottom, and then the other 2 get crossed on top. 8 sine of 120. Type it in and round. Alpha x, 8 sine of 120 over sine of 23, 17.7. Now we need to find side C, and we're going to have to do it again with the law of sines. And as I've been saying, I'm going to use the B's since those were given to me. Sine of, not B, C. I was like, wait a second, I already know B. C. There we go. I'm using the B's, that's why I was thinking about the B's. And once again, I am choosing B because it was given. So we have sine of 23 over 8, and then sine of C was 37. C equals, whatever gets crossed with C goes on bottom, sine of 23. And then 8 sine of 37 goes on top. Then I can just grab what I did last time and change it. And we just need to change 120 to 37. $12.3. Okay, that was the last solving problem, so we can be happy about that. Full solve. On some of the areas, we'll have to solve a little bit, but not nearly as much. Okay, area. Can actually fit some of these on the same piece of paper. Number 7. This time we are finding area. Let me clarify that. A equals 5, B equals 3, C equals 7. On the test, I made it very obvious which ones are the area problems because I put area in the answer box, so it's going to be really hard to miss that. At least that was the intention. Okay. Now, the picture's not 100% necessary, but a lot of people like a visual, so I'm going to draw it anyway. A, B, C. A, B, C. A is 5, B is 3, C is 7. Okay. So here are your formula options for area. You can either use the Heron's formula or the SAS triangle formulas. Now, to use the SAS as it's implied, you have to have the SAS set up as far as your information. So if you don't have SAS, you can't use it, but this is one you can easily get there with the triangle with some solving. Heron's formula, you must know all 3 sides of the triangle. Obviously, that won't be on your formula sheet, but you're welcome to write it when you get it. So, since I do know all 3 sides, I'm going to use Heron's formula. And remember, Heron's formula, as you can see, is 2 parts. You have to find the S first because the S gets plugged into the area part. So, we're going to do S first. So, we have S equals A plus B plus C over 2. We have 5, 3, 7. No matter, this decimal will never be large. It'll be up to 1 or 2 places. It depends on what kind of number you get on top. So never round this number. 5 plus 3 plus 7 over 2. And I'm going to turn that into a decimal. That happens on your calculator. It is alpha y equals, you want that F1 menu. And the fraction decimal converter is what I need here. 7.5, my goodness. So there's S. Now I can use the area formula, so I'm going to write that out first. A equals the square root of S times S minus A, S minus B, S minus C. And I have a feeling it's going to take more room than that, so I'm going to scooch over just a little bit. S is 7.5 times S minus A, 7.5 minus 5, times S minus B, 7.5 minus 3, times S minus C, 7.5 minus 7. And then we type all of that into the calculator very carefully. So take your time on this. We have 7.5, 7.5 minus 5, 7.5 minus 3, 7.5 minus 7. And, per usual, round to the nearest tenth, 6.5. And there's no units given, so I'm just going to write U squared, U for units. All right, 3 more. Number 8. Again, this is an area problem still. Our givens, the measure of angle A is 53 degrees. C is 17 and B is 20. triangle ABC, little a, little b, little c. Filling in the information, angle A is 53 degrees, and side B is 20, side C is 17. So we have a side, angle, side. In that order, the angle is between the two sides, so this is SAS. So we can very clearly use the SAS triangle formulas. And we have angle A, sides B and C, so we're going to be using the top formula here. I'll write it out. A equals 1/2 B times C sine of A. 1/2 B is 20. C is 17. Sine of A is 53. And then we use our calculator. $135.8. And again, we're still sticking with u squared. Okay. 2 problems left. Number 9, again, this is area. We are given measure of angle A is 120. Measure of angle B is, oh, I looked at the wrong one. Hold up. Started to write down the numbers for number 10. Okay, let's try that again. Measure of angle A is 63 degrees. Side A is 18 and B is 15. There we go. Picture A, B, C, little a, little b, little c. Angle A is 63 degrees. Side A is 18 and side B is 15. We have an angle right here and 2 sides. Not the sides around that angle, so this is ASS. Not an issue if it's area, obviously, but it doesn't fit into either of these 2 categories, not immediately. So here's where you have 2 options. You can either find the third side and use it to use Heron's formula, or you need to find an SAS trio of information to use these formulas. So you would either need to find side C, because then that would create SAS. We could use this grouping here. Or you would need to find angle C, because that's what's in between the S's. Either one is doable. Actually, you can't find side C immediately because you don't have enough information. So, or sorry, angle C, that's what I meant to say. Can't find angle C. So, and actually, we're going to have to do a little bit more work here now that I'm looking at this. So the goal is to either find side C or angle C. I will always opt to finding a missing side because, again, when you use the angle, that's where we get into murky water with the law of sines, the inverse sign. So avoid that if you can. So we have, we can find angle B. That's where we can start because we have the A's and then we have side B. So we're going to have to do angle B from here. That's the only way we can move from this point on, is find angle B. So we have sine of A over A equals sine of B over B. And we have sine of 63 over A is 18 equals sine of, we don't know B, over side B, which is 15. Cross multiply. And again, I'm going to skip the algebra on this. Sine of B equals whatever gets crossed with sine of B. We have that on the bottom, so 18 on bottom. And then 15 sine of 63 on top. And then we're going to have to use the inverse here. Not ideal, but that'll be okay. Inverse sine of 15 sine of 63 over 18. Whoops, I need to do the inverse sine first. Second sine of 15 sine of 63. Good Lord, I am messing up all over the place. Let me try this again. Second sine and then alpha x to get the fraction. Okay, B is 47.9. So that's angle B. And I do want to take a moment here real quick because the reason I was so off when I was using my calculators, I was thinking about, this is not a great problem. So we would not do this to you on the test. I just want to throw that out there because of the ASS and you having to solve it a bit. There is that ambiguous case thrown in there again. Could I have a second triangle that I would also have to find the area of? Let me ease your mind. If you don't recognize these numbers, I know it's been over an hour, so probably not. This is number 1. That's where we took these same numbers. So like, oh, find the area. And remember, this one only had 1 triangle. So if you're having any fears about, oh my gosh, do I have to find a second triangle? No, we already know it fails. And like I said, we would not give you this on the test. We just want you to find the area, and not very painfully either. So you will not be given an ASS area on the test. I just want to let you know that in case you were wondering about that. So I'm going to pretend that I don't know it's ASS, and I'm just going to continue with my life and find the area of this triangle. Okay, so next we know 2 sides and we know 2 angles. Let's find that third angle. We have 180 minus 63 minus 18. Third angle is 9. Is that what I got the first time? What? Yeah, no. Let me try that again. 180 minus 63 minus 47.9. There we go. 69.1. Okay. And if needed, I'll write it out. Which, let me check my work. Yep, that's what we got the first time too, so it checks out. All right, so let's reevaluate. We need SAS if we're going to use these formulas. So we do finally have that. Our 2 sides here, A and B, we have the angle in the middle, angle C. So I can use the SAS formula. So our parts are A, B, and angle C. So make sure your parts match before you plug it in. So we're going to use the bottom one, AB angle C. A equals 1/2 A times B sine of C. 1/2 A is, covering up my work up here, 18. B is 15. And sine of C is 69.1. One half, 18, 15, sine of 69.1. Okay. The area is 126.1 units squared. All right, we have one problem to go, number 10. Area problem. Angle A is 120. Angle B is 23 degrees. And side B is 8. This is more like one you would see on the test. This one's not an ASS, so it's a more straightforward. Less work. A, B, C. Little a, little b, little c. Angle A is 120. Angle B is 23 degrees, and side B is 8. We have two angles and then a lonely side. So this is AAS since the S is not between the two angles. Okay, so we do not have SAS, so we can't use that, and we definitely can't use Heron's because we're missing two sides. So looking at this, we could, the most straightforward thing to do would be to find side C if we're able to, which we have the B's, and then we have angle A. So I guess the best way to approach these area problems is do what you can from the start and then kind of go from there. And actually, I just realized we're missing this angle, so let me do that. That'll save me some time. First, let's find angle C. And actually, that will get me where I was wanting to go anyway. 180 minus 120, 23. $37. Okay. Next, we could either find side A or side C. And actually there is no right or wrong way to go about this. You could find either of them and that will give you what you need. Because if we have B and C, we will have BAC, SAS to use the formula. Or if we find A, then we will have sides A and B with side C and the angle C in the middle, and you can use that for your area. So this really is personal preference. Since I can never make decisions, I always go alphabetical order. Let's find A. If you do C, your answer may be up to 0.1 off of mine, but it doesn't make a huge difference. Okay. So we have the B's were given to us, so I'm going to use sine of B over B. Equals, and I'm looking for A, so sine of A over A. So the B's, we have 23 over 8. And then the A's, we have 120 for angle A, and then side A is unknown. Cross multiply. A equals, whatever gets crossed with A will end up on bottom. Other two numbers cross on top. And then we'll round. $17.7. So that is side A. And now I have the SAS set up I need to use the formula. So I'm going to use sides A and B with angle C to get the area. Which I believe is what I used last time. Yep. So A equals 1/2 A times B sine of C. A is 17.7. B is 8. Sine of C was 37. And we round. Okay. 42.6 units squared. And we are done with the study guide. I hope this video has been helpful to you all. I hope you were able to learn something from it, or just able to make you feel more comfortable with the material prior to the test. If you have any questions, you are more than welcome to reach out to me via email or come see me in person. Otherwise, I hope you have a wonderful day. Bye.